Alright, hi guys. So in this video, I'm going to do a quick recording of this chapter called Light. Okay, and so if you're taking pure or combined physics, then you can use this as a quick revision before you start doing your practice questions lah. Okay, so I'm going to split this up into a few different segments so that you can just watch selectively the ones which you feel like you need a bit more help with. Okay, and so without further ado, let's get started with one of the first few learning objectives. Okay, so light, right, you can split it into three main parts. Okay, so firstly you have the reflection of light, followed by the refraction of light, and finally also learning how lenses, in particular converging lenses, work. Okay, so in this very first video, right, I'll cover the concepts of reflection. Okay, so if you take a look at the very first learning objective, so Cambridge wants you to know what the terms normal, angle of incidence, and angle of reflection are, in order for you to talk about how light occurs, or rather how reflection within light occurs. Okay, so the next thing that they want you to also state is that there's this important rule, which is that the angle of incidence is equals to the angle of reflection. Okay, and you should also know the rule called the law of reflection. Finally, they also want you to be able to know how to solve problems involving reflection. Okay, so if you take a look at the notes, so you can download this from the website. These are a few main properties of light. Okay, the first thing is that light travels in straight lines, and it is a form of energy. Okay, so light has this speed which is 3 times 10 to the power of 8 meters per second. Okay, and so notice, right, that when light hits a surface, if it's opaque, right, it will undergo reflection. So it looks something like this. Okay, and now importantly, whenever you undergo reflection, right, you can actually draw out a normal. Okay, so what is a normal? A normal here, right, refers to a line that is right angle, right, to the surface. So notice that the surface here, right, is at this very nice right angle to the normal. Okay, and now we have two very important angles to talk about lah. The first one is the angle of incidence. Okay, so let me label that as I. This angle of incidence, right, is measured from the incident ray. Okay, so this is the incident ray to the normal. And then the angle of reflection is actually measured from the reflected ray to the normal. So it looks something like this. Okay, and so one of the most basic rules, right, in this chapter is that for reflection, right, the angle of incidence is equals to the angle of reflection. Okay, and yeah, whenever you undergo reflection at like opaque surfaces, then the diagram looks something like this. Okay, and on the other hand, right, if let's say the object, right, is transparent or translucent, then actually some refraction can occur. Okay, so refraction is this side. This is when the light, right, doesn't pass straight through, but instead it bends. Okay, and even for the case of the refraction, right, we also usually would draw the normal. Okay, and so once again, the normal is just a line like this, right? We usually draw it as a dotted line that is right angle to the surface line. Okay, so yeah, this is pretty much the reflection of light. Okay, so notice, right, reflection of light actually helps us to see everything. Okay, so whenever you look at something, right, and you can perceive it, right, the idea is that the light is bouncing back into your eyes, and so that's how you can see something. Okay, and so we talked about the incident ray as well as the reflected ray. Okay, so these are their definitions. The incident ray is just referring to the light ray that comes towards the surface, whereas the reflected ray, right, is the light ray that is bouncing off the surface. Okay, so yeah, this is pretty much how reflection can be thought about. Okay, so I'll show you a couple of examples of reflection. Now, if you have a very smooth surface, right, we actually call this reflection regular reflection. Okay, so notice, right, that you have like parallel rays of light, right? Okay, or you can call them like beams of light, right? So these are the light rays. And when there are multiple rays that are parallel coming together through a regular surface, they actually rebound parallel as well. Okay, and this should be no surprise. The reason is because the angle of incidence, okay, is going to be the same for both of them. Right? So that's it. So remember, right, that if the angle of incidence is equals to the angle of reflection for all your reflected diagrams, right, then you know that both of them, right, when they undergo reflection, they will also be parallel to one another. Okay, so whenever you look at a very smooth surface, right, this is how the diagram looks like. Okay, and on the other hand, right, if you have a rougher surface, okay, so when I say rough, right, it could be something like if you look at the walls that are around your house or the walls that are in your school, right, it might appear smooth, but if you really zoom in, right, you can see that actually the surface, right, has a lot of imperfections like this. Okay, so like if you take a look at any white painted wall, right, it typically looks something like this. Okay, so if you zoom all the way in on a microscopic scale, notice that it's not a smooth surface anymore. Okay, and so you look at all the normals that are drawn here, right? The normals here, right, are not actually all parallel to each other. Why? Because the surface is not smooth. Now look at the top diagram, right? When the surface was smooth, the normals are actually parallel to one another, right? And on the bottom diagram, it's because the normal, right, is not all parallel to each other, because the surface is not smooth, that you actually don't get parallel beams of light being reflected off. Okay, and so this is what we call diffuse reflection. Now, I want to highlight one important point though. So in both cases, right, whether or not you got a regular smooth surface or irregular surface, right, notice that the angle of incidence, right, is always equal to the angle of reflection. Okay, this will always be the same. So what I'm trying to say is this, look, for any of these reflected rays below, if you observe the normal, right, and the angle of incidence, as well as the angle of reflection for any one ray, this angle is always equals to this angle. Okay, so same, we can look at the second diagram, right? So this I equals to this R also. Okay, so there's this very important rule which states this: the angle of incidence must be equal to the angle of reflection. It's just for this case that because the surface is not smooth, then your reflected rays are not parallel to one another. And when they're not parallel to one another, right, then we can say actually the surface, right, appears rough. Yeah, so that's the thought process behind this. Okay, so yeah, this was one of the most important laws of reflection, right? That the angle of incidence is equal to the angle of reflection. Now this is only one of the laws, so there's a second law. Okay, the second law of reflection states that the incident ray, the normal ray, sorry, not the normal ray, just the normal, the incident ray, the normal, and the reflected ray, right? So all three of these, incident ray, normal, and reflected ray, they must all lie along the same plane. Okay, so yeah, this is one of the rules that you have to remember. Okay, so in total, right, law of reflection, I got two. Must know how to state both. Okay, so a lot of exam questions will test you on this. Okay, so yeah, that is pretty much the very first section. So I flip all the way back to the top again, and I want you all to see which particular terms we've already covered and which objectives we are done with. Okay, so we're done with the very first one, using and defining the normal, angle of incidence, and angle of reflection. So done. Okay, then we've also done the statement of the two laws, right? Where the angle of incidence equals to the angle of reflection. Okay, and so yeah, we can strike this off as well. We've also done the third one, where we talk about how the normal, the angle of incidence, and angle of... Oh, actually, sorry, we're not done with number C. This one is for refraction. Right, so yeah, I'll cover that in the next video. Okay, but before I close off this video, I also do want you to take a look at a very important, commonly tested thing. So now, you must also know how to describe the images, right? Whenever they give you a mirror, like a plane mirror image. Okay, so this is exactly what we mean by a plane mirror. Now, I want you to think of just any mirror, right, where the surface is flat. Those kind of surfaces, we call them plane mirrors. Okay, so for example, you can take a look at this. This dotted line actually represents the plane mirror. Okay, and so notice that you have an object here. Then some of the exam questions can test you, right, to sketch out the light rays, right, so that you can form the image. Okay, and so this is like a very simple sketching kind of question, and it can be worth up to 3 marks. Okay, so usually they'll give you the object, they'll give you the mirror here, but they won't give you the image. And then our job, right, is to actually sketch out the image. Okay, so for this, right, sketch out the image as well as the light rays. Okay, so for these kind of questions, it's actually quite straightforward. There's a couple of steps that you must follow. Okay, so I've listed them below actually. So you can flip over to page 4, right? And so these are the steps whenever you're tasked to draw a plane mirror light diagram. Okay, so step 1 is this. If they give you the object, right, just make sure you measure the distance from the object to the mirror here. Okay, and make sure, right, that this line that you've measured, right, this here, is actually right angle to the surface. Okay, then however long you've drawn this line, right, or you've measured the line, let's call this X. You must go and measure the same length, like this, to the other end, and then draw the image here. Now, do you need to go and draw the 2 lines like that? Or do you even need to draw this entire line when you're sketching out your diagram? Actually, the answer is no. You do not draw this line. But you need to make sure that when you measure, right, this length X is the same as this length X. Okay, and you must also make sure that it's right angle to the mirror. Okay, So once you're done with that, right, you've actually identified the position of the image lah. Okay, so yeah, that's pretty much step 1 done already. Okay, now after you're done with that, then the very next thing you need to do, right, is from the image right here. From the image here, you want to draw a straight line to the eye. Now usually we draw 2 rays lah. So one of them going to the top of the eye, the other one going to the bottom of the eye. Okay, and then only right in the region where the object and the eye is, right, then you make the lines solid. Okay, these are real rays. Okay, so I'm talking about this section. These rays are real. Okay, so you make sure that the lines that you sketch out there are solid. Okay, however, in this region, these rays, right, are not real. They're actually virtual rays. They were done to just get our working. Okay, so that's why you draw them as like a dotted line. Okay, so that's written here. Make sure you use dotted line to represent the virtual rays. Okay, then after that, make sure that you sketch your final last incident ray. Okay, so remember, right, that the light ray actually comes from the object to those 2 points here. Okay, so let me sketch it a bit nicer. These 2 points, here and here, before they bounce into your eye. So similarly, you just go from the object, right? You make sure you sketch these lines here. Okay, then after that, make sure you label the arrow for the light rays. Okay, don't screw this up. So a very common mistake I've highlighted here, right, is that some students will get the direction wrong. Make sure that the light ray is going into your eyes, not the other way around. Okay, because some people, when they draw, right, they think that they are cyclops. Okay, and then the light ray will come out from the eye one. Okay, that's clearly wrong. Okay, so here make sure that the light rays always come from the object, reflect at these 2 points to the eyes. Okay, and I also highly encourage you to sketch out the normals here. Okay, so yeah, this kind of question can easily get you 3 marks. You just got to be careful and meticulous, and you can get the full credit really. Okay, so yeah, I think it's quite straightforward lah. Now, one last thing I want to emphasize is some exam questions will also ask you the characteristics, right, of plane mirror images. Okay, so you must know all 5 of these characteristics. Firstly, the one characteristic of a plane mirror image is that it is virtual. Okay, what does virtual mean? Virtual means, right, that the image, right, cannot be captured on a screen. Okay, so that's the definition of a virtual image. Okay, so next thing. Okay, actually, right, for this one, I think a lot of people don't really understand what it means when I say that the image can't be projected on a screen. Okay, so I want you to sort of visualize this. Now imagine if you go to your house, right, and you stand in front of the mirror. Now when you look in the mirror, it appears as if you can see yourself, right? Okay, however, what happens, right, if, let's say you took away the mirror, and then you were just standing in front of a wall. Now notice that your image, right, is no longer present already, right? So that image couldn't be projected on the screen. Okay, similarly, I can explain it in a diagram for you also. Imagine if, let's say, right, this is you, okay, and then this was the mirror, okay, and then let's say this is your friend. Okay, so let's call this this is me, this is Iman. Okay, so this is, sorry, one sec. This is Iman, and then this is my friend. Okay, let's say my friend is Bob. Okay, so right now, right, this is the mirror. Okay, and actually I am being looked at by my friend. Okay, so something like this. Okay, so I send a light ray to Bob. Now, okay, notice, right, that Bob, right, can see my image through the mirror. And to Bob, right, notice that my image will appear somewhere here, right? So this is Iman's image. Okay, so wait, it's not very accurate. Okay, but it should look something like this. Okay, if I extend this out, it should be a straight line that looks like that. Okay, so, okay, yeah, that was quite bad. One sec, let me draw a bit neater. Okay, yeah, so this is how it should look like, right? These are the virtual dotted rays, like this. Okay, and so you know that the image, right, that Bob sees, which is this, is a virtual image. Okay, which means, right, that if actually I remove this mirror, then I try to put a screen instead. Okay, so you can see, right, this is the mirror. Let's say I take away the mirror and I put a screen, something like this. Then actually notice, right, that nothing will be cast on the screen. There won't be an image actually shown on the screen. You can only see it when there's the mirror, right? Yeah. So that's what it means when we say that the image, right, is virtual. It cannot be projected on the screen. If I replace this with just a normal screen. You wouldn't see a picture on the screen of me. Yeah, so that's what we mean by a virtual image. Okay, so yeah, that's the definition of a virtual. So let me go down a bit. Oops, sorry, one sec. It's here. Yeah. So yeah, we're done with this. Okay, then you also have a couple of other things to care about. So the next thing to care about, right, is about the orientation of the image. So we also mentioned, right, that the image is actually upright. Okay, so when you go and brush your teeth, right, when you're standing up straight, you take a look at your mirror image, right, it's also standing up straight. Yeah, so all your plane mirror images are also upright. Okay, now then there's also a lateral inversion, okay, which is very simple to see lah. Okay, so lateral inversion you can see like this. When you have an object, right, that looks like an L shape, then when you look at its mirror image, right, it's actually the other way around. Okay, so it looks something like this. Yeah, that's the meaning of a laterally inverted. Okay, so yeah, we are done with learning objective, or rather we're done with these 3 characteristics. Okay, so there's 2 last characteristics you must also know. The object, right, will be the same size as the image. Yeah, so this is another feature you have to understand. Okay, so we'll call this learning objective 4. Okay, and then finally, the very last characteristic that you have to remember is that the distance, right, from the object to the mirror must be the same as the distance from the image to the mirror. Okay, so physically, right, it looks something like this. This distance must be exactly the same as this distance. Yeah, so these are the 5 characteristics that will always show up for all your images. Okay, this will always be true for plane mirror images. Okay, so yeah, we are pretty much done with the very first few learning objectives A and B. Okay, so in the next video, right, I'll walk through the next few learning objectives about refraction instead. Okay, so yeah.